Hey there. Welcome back. You've given us some really interesting stuff to dig into today.
Oh, yeah.
Yeah, excerpts from Why We Sleep,
Mhm.
Unlocking the Power of Sleep and Dreams.
Okay. Fascinating.
And we all know, of course, sleep's important.
Right.
But I have a feeling that what we're going to uncover in this deep dive is just how much, it really impacts every single part of your life.
Yeah.
So our mission today, as always, is to, dive deep into this material, pull out the really essential knowledge, the surprising science,
Mm.
and give you, the listener, a true understanding of, this whole topic without making you feel completely overwhelmed.
Exactly. We're here to boil down this wealth of information right into those core insights about sleep,
Yeah,
why it matters so much, and maybe even in ways you haven't fully thought about before.
I think you're right. So let's start with a simple question, right, for you, the listener.
Sorry.
Think back over the past week. How's your sleep been? Can you easily recall a morning where you woke up and felt truly refreshed, like you didn't need an alarm, you didn't need that first cup of coffee?
Yeah.
Because, and this is right from the book, like a pretty striking fact, about 2 out of every 3 adults in developed countries aren't getting the recommended 8 hours.
Yeah, it's widespread for sure. And, that number might sound familiar. We've all heard something like that.
Yeah.
But what's really eye-opening, I think, are the consequences, the truly far-reaching and serious consequences of this chronic lack of sleep. And it's often kind of lurking beneath the surface. We don't always realize it.
It's so true. And the book lays out some pretty stark realities. I mean, we're talking your immune system taking a huge hit, like more than double your risk of cancer.
Wow.
It's also highlighted as a really big factor in developing Alzheimer's disease. And then get this, even just 1 week of getting slightly less sleep than you need can throw your blood sugar levels off to the point where they resemble someone who's uh, pre-diabetic.
So it's not just sleep is good for you.
Right, yeah.
It's that skimping on it has these profound, interconnected negative effects on basically every system in your body and brain.
Yeah,
This foundational pillar of health
total,
that's
yeah.
being actively undermined.
Yeah.
And it just keeps going,
Yeah,
right?
it
It has
does. It
consequences.
really does. So insufficient sleep increases your risk significantly of developing blocked and brittle arteries,
Oh,
which
wow.
can lead to cardiovascular disease, stroke, heart
All
failure.
right.
And it's not just the physical stuff, right?
Sure.
The book quotes Charlotte Bronte, who said, a ruffled mind makes a restless pillow, which
What?
I love, because it really highlights that deep connection between, how we're feeling mentally and emotionally and how we sleep. And the book goes on to really emphasize how, sleep problems can contribute to major psychiatric conditions,
Right.
depression, anxiety, and even thoughts of suicide.
It's almost like a chicken or egg question, isn't it? I
Yeah.
mean, do mental health issues disrupt sleep,
Yeah.
or does poor sleep contribute to mental health problems?
All right.
I think increasingly it's clear it's kind of this dangerous cycle, right, where each can make the other one worse.
Totally. Yeah. And then, we have to talk about the really alarming issue of drowsy driving.
Absolutely.
Hundreds of thousands of accidents every year and,
Yeah.
tragic fatalities.
Yeah.
Someone dies in a fatigue-related car crash roughly every hour in the United States.
Wow.
And here's the sobering comparison. The number of vehicle accidents that are caused by drowsy driving is actually greater than those caused by alcohol and drugs combined.
It's chilling, really. What's particularly I guess disturbing about those drowsy driving accidents is often there's just no reaction at all.
Yeah.
Like someone who's had too much to drink might still try to brake or swerve,
Right.
but someone who's fallen asleep at the wheel, they often just don't even try to avoid a collision. I remember that image from the book, this 1-ton missile, and it really makes you
Yeah.
think about the potential consequences.
It's terrifying. And it makes you wonder why it's not talked about with
Right.
the same urgency as some of
Right.
these other, public health risks.
Yeah.
And the book even describes it as uh, the most glaring omission in the contemporary health conversation.
Which leads to a really interesting point, and I think you touched on this earlier, is, for a long time, science couldn't fully explain why we sleep.
Yeah.
We understand, things like hunger and thirst, reproduction, those are fundamental drives.
Right, yeah.
But sleep was this kind of mystery.
So, okay, let's break that down a little bit. From an evolutionary standpoint, being asleep seems like incredibly risky.
But totally. Yeah.
I mean, you're vulnerable to predators.
Yeah.
You can't, forage for food.
Right.
You can't find, mates or protect yourself, protect your offspring or
Yeah,
family.
you're totally exposed.
It is. The book calls it the most foolish of biological phenomena.
Yeah, it's a period of profound inactivity and vulnerability.
Yeah.
And yet it's a behavior that's preserved across the entire animal kingdom.
That's so wild.
Which suggests to me, whatever the benefits are, they've got to be absolutely crucial to have been maintained throughout evolution.
Yeah, it's a puzzle, this evolutionary puzzle.
It is, and it makes us even more curious, like, what's the core purpose here?
But here's the good news. The central message coming from what's called a research renaissance in sleep science
Okay.
is that sleep is the single most effective thing we can do to reset our brain and body health every single day.
Wow.
I mean, the book says it's Mother Nature's best effort yet at contra death.
Okay, that's a strong stiction.
Yeah, a big statement, yeah?
It really emphasizes how vital it is for life and health.
Yeah. Okay, so we've established how critical sleep is, how
Yeah.
much we need, and how often we fall short. Let's actually delve into, the mechanics of it.
Right. Okay.
What governs when we sleep and when we're awake. And the book introduces us to two main players, the circadian rhythm, which is also known as process C, and then sleep pressure, which is driven by a chemical called adenosine, or process S.
Okay, so these two kind of work together
Yeah.
in this really dynamic way to regulate our sleep-wake cycle.
Yeah, let's start with the circadian rhythm. So think of it as your internal, 24-hour biological clock.
Okay.
It helps to synchronize your body's processes with, the day-night cycle of the Earth.
Right.
And the most powerful cue to set this clock, you know what it is? Daylight.
Which is fascinating to think about because, the very first scientific evidence of this internal biological time in living things
Yeah.
goes way back to 1729.
Wow.
Jean-Jacques Dortu de Miron, he did this experiment with the Mimosa pudica plant.
Oh, right, yeah.
You know those sleeping leaves that Darwin later observed?
Uh-huh.
So he showed that even when this plant was kept in complete darkness, its leaves still opened and closed on this, roughly 24-hour cycle.
Wow, that's amazing. So even a plant
Right.
has this kind of internal clock.
Totally. And it makes sense, right, that daylight would be that strongest reset button.
Yeah.
Because it's the most reliable, predictable signal from our environment, given the Earth's rotation.
Yeah. Now we got to talk about morning larks and night owls, or scientifically, our chronotype.
Chronotypes, yeah.
Turns out, our natural tendency to feel more alert earlier or later in the day, it's not just a preference.
Right.
Like some people are just, oh, I'm a night person.
Well, there's a big genetic component that influences your chronotype.
Yeah.
And, the issue here is that our modern societal structures, right, like work schedules, school schedules,
Right, they're designed for larks.
they're heavily geared toward the larks, which can create real problems for the owls.
And this is where it gets, I think, really interesting.
Okay.
The book points out that, these standard early start times are forcing night owls to live against their natural biological clock.
It's true. They have to wake up early like the larks, but their natural bedtime is much later.
Right, so they're constantly in this state of sleep deprivation.
Chronic sleep deprivation.
Yeah.
And that's not just about feeling tired.
Right.
It has significant health consequences.
Yeah.
Owls who are forced to, burn the candle at both ends,
Right.
they experience higher rates of depression, anxiety, diabetes, cancer, heart attacks, stroke.
It's huge.
Yeah.
It really is. And it makes you realize how much like societal norms can clash with our basic biology.
For sure. For sure.
Okay, let's switch gears a little bit and talk about the second key player in regulating sleep, which is sleep pressure
Okay.
and the role of this chemical adenosine.
So adenosine, it's a neurochemical that builds up in your brain throughout the day, throughout your
Okay.
waking hours. You can think of it like almost like a byproduct of your brain's activity.
Okay.
The more adenosine accumulates, the stronger that urge to sleep becomes.
Okay, so that's the process S, the sleep pressure.
Exactly. That's the process S in action.
And this is where our friend caffeine comes into play.
Ah, yes, our friend caffeine, that go-to pick-me-up
Pick me up.
for so many of us.
So how does it actually work?
So caffeine works by blocking the adenosine receptors in your brain.
Okay.
So it doesn't actually get rid of the adenosine, it just prevents it from making you feel sleepy.
So it's like a temporary, block.
Exactly. It's like a temporary block on that feeling of tiredness.
Right.
But the adenosine is still there in the background,
That's still
quietly
there.
building up.
I see. Okay.
And, the speed at which your body processes and clears caffeine can vary a lot from person to person.
Yeah.
Our genes, as we age, those things can influence it.
Right.
So some people have a more efficient liver enzyme that breaks down caffeine quickly,
Oh.
while others, have a slower version, and they tend to be more sensitive to the effects.
Right.
And, generally as we get older, it takes longer for our body to clear caffeine.
So that's why that afternoon cup of coffee can mess some people up so badly and other people are totally fine.
Exactly. Yeah, it affects people differently.
Yeah. And the book, cautions about this potential cycle of dependency that can happen,
Right.
where you end up needing more and more caffeine to counteract
Right.
those ever-increasing adenosine levels.
It's like a biological arms race,
Totally.
trying to outsmart your own natural drive for sleep.
Yeah. And to illustrate how potent caffeine's effects can be, the book brings up this NASA experiment. You
Yeah.
probably remember it. Yeah.
From the 1980s, the one with the spiders.
Yeah. The spider webs.
Spider webs. They gave spiders different substances, including caffeine,
Right.
and then watched the webs they built.
And the webs were crazy, the
Oh,
caffeinated
yeah.
spiders.
Super chaotic. And even when compared to the webs of spiders that were given, LSD or amphetamines,
Oh, wow.
the caffeine-induced webs were just really disorganized and structurally flawed. It's a weird experiment,
Yeah.
but it really makes you think about how caffeine can disrupt even those complex instinctual behaviors.
It's a vivid image. Okay, let's go back to the adenosine.
Okay.
And the book uses this figure 4, to show how sleep pressure, that rising level of adenosine,
Right.
interacts with our circadian rhythm.
So you can actually see it visually.
Yeah.
So in the morning, after a good night's sleep, your adenosine levels are nice and low,
Okay.
and your circadian rhythm is going strong, promoting alertness.
Right. So that's why we typically feel, most awake at the start of the day.
Exactly. But as the day goes on, adenosine gradually builds up,
Oh, yeah.
creating that sleep pressure. If you're feeling super sleepy mid-morning, that's often a sign that you probably didn't get enough quality sleep the night before.
It's like a sleep debt.
Exactly.
A little bit of a sleep debt.
Yeah, it's a lingering effect of that adenosine buildup.
So it's not just a random energy dip.
Nope. Your body's telling you something.
It's a message. Okay, so what happens when you actually fall asleep?
Okay, so when you finally drift off, it's like this
Yeah.
mass evacuation.
Yeah.
Your brain starts working hard to clear out all that accumulated adenosine.
Okay.
Sleep essentially lifts that heavy weight of sleep pressure.
Okay, I like that. So figure 6 actually shows how this works, right?
Yeah, it
Yeah.
illustrates it beautifully. After about 8 hours of healthy sleep, that adenosine purge is usually complete. And right around the same time, your circadian rhythm starts to ramp up again.
So it's perfect timing.
Yeah, like perfect coordination. So low adenosine, rising circadian drive, that equals waking up feeling refreshed.
That meeting point of the lines in the graph.
It's beautiful, isn't it?
Yeah.
Shows that interplay.
I like that. And so then you're set up ideally for another what, 16 hours or so of wakefulness?
Yeah, about that. Fully charged, both physically and mentally.
That's the ideal scenario.
Absolutely.
Okay, so we've looked at the when of sleep, those two processes. Let's move into the what of sleep itself. And the book starts with this, kind of relatable scenario. You see someone, Jessica's still on the couch.
How much do I go?
Yeah, but you just, they're asleep. It's not a coma. It's not, they're not dead,
Yeah,
obviously.
right.
So what's actually different in the brain?
It's a simple observation, but it gets to the heart of how we define these states of being, right?
Yeah.
Wakefulness, sleep, and those other states of reduced consciousness.
Okay.
And the key really is the electrical activity in the brain.
So the book explains that during wakefulness, our brain activity is, fast and desynchronous.
Exactly. Yeah. Lots of different brain regions all firing independently.
Yeah, lots going.
Lots going on. But then we transition into NREM sleep, particularly those deeper stages, and that activity changes dramatically,
Right.
especially in deep, slow wave NREM sleep. That electrical activity really slows down.
Okay.
It oscillates at like 2 to 4 waves per second.
Wow.
And these slow waves are also way more synchronous and consistent across different brain regions.
I love that analogy in the book about the microphone above the football stadium.
Oh, such a good analogy.
Yeah. So, during wakefulness, it's like all the individual conversations, the shouts of the crowd.
And everyone's doing their own thing.
Exactly. But deep sleep, it's as if the entire stadium is chanting in unison.
Yeah. It's a powerful rhythmic roar.
It's so cool. It's so cool to visualize that.
It really highlights that deep sleep is an active, coordinated state. It's not just shutting down.
Yeah, it's not hibernation.
It's not hibernation at all.
So this sort of electrical harmony,
Yes.
that explains why we lose awareness of, what's happening around us during deep sleep, right?
Exactly. The thalamus, which is that relay station deep in the brain, it blocks the transmission of all those sensory signals up to the cortex.
So it's blocking those connections.
Blocking those connections, yeah. So we lose consciousness. And, that's also why we don't typically dream in deep NREM or even really have a sense of time passing.
It really does allow the cortex to relax into this, slow wave activity.
Right. Almost like a nocturnal cerebral meditation, although the brainwave patterns are a little different from, waking meditation.
Okay. What happens when we switch over to REM sleep?
Ah, yes, the dream stage.
Yeah, the dream stage. What's happening then?
So REM sleep, it's almost the complete opposite of deep NREM in terms of brainwave activity.
Okay.
Instead of being slow and synchronous,
Right.
it looks a lot like someone who's wide awake and alert.
Yeah.
It's fast, desynchronous.
So the brain is behaving as if it's awake,
Right.
even though the body is basically paralyzed.
Exactly. It's this really strange paradox, isn't it?
Yeah, it is. It is. And the book mentions, using MRI studies, they discovered that certain areas of the brain are up to 30% more active during REM sleep than when we're actually awake.
30%. Wow, that's wild.
It's mind-blowing.
So if wakefulness is about taking in information,
Right.
deep NREM is, that internal processing,
Hmm.
then REM sleep is something else entirely. It's this like supercharged state of
Yeah.
brain activity while we're technically asleep.
So interesting. Okay, the book then explores the differences in how much sleep different animals need.
Oh, yeah. Fascinating stuff. It's not just about size or metabolic rate.
Yeah.
You've got some creatures that sleep for a few hours a day. Others spend most of their time asleep.
It's a huge range.
It is. And it's this, complex web of factors that determines how much different species need.
So what are some of those factors?
Well, things like their diet. Carnivores, for example, often sleep more than herbivores.
Oh, interesting.
Predator versus prey, the complexity of their social structures, metabolic rate,
Okay.
how sophisticated their nervous system is, all of that contributes.
It shows how, sleep has been shaped by, like, so many different evolutionary pressures.
Absolutely, yeah.
So there's no one right amount.
Right, exactly. It depends.
It depends.
And you get these truly remarkable examples in the animal kingdom, like unihemispheric sleep in dolphins and
I
whales.
love that. It's so crazy.
They can literally sleep with only one half of their brain at a time,
Really?
and it's only NREM sleep. So the other half is wide awake, keeping them breathing, swimming,
That's crazy.
doing all the things. It's incredible.
We can't do that.
Nope, humans can't do that. We need both hemispheres of our brain to be in some stage of NREM sleep at the same time.
Yeah.
And even more universally, no species can split REM sleep across hemispheres.
Interesting. So it needs both sides of the brain.
Yeah. Whatever REM is doing, it needs the whole brain involved.
So interesting. The book also talks about how extreme environmental pressures can sometimes override the need for sleep.
Right. Yeah, in survival situations.
Yeah. So, for example, like severe starvation.
Right. If there's a lack of food, the drive to find food becomes more important than sleep, at least for a while.
Okay. So the brain prioritizes survival.
Exactly. It kicks into this survival mode.
Got it.
And then you have that postprandial alertness dip.
The afternoon slump.
The afternoon slump. Exactly. It's evolutionarily ingrained.
It's like a little siesta time.
It is.
Yeah.
It is. The book actually jokes about, avoiding important presentations mid-afternoon if you can, for everyone's sake.
For everyone's sake,
Yeah.
exactly.
It seems like we're kind of wired for that afternoon rest.
Totally. Totally.
So that leads into the discussion of biphasic sleep.
Oh, yeah.
And the book sort of, I think, clarifies the historical understanding of these patterns a little bit.
That, that this idea of pre-industrial Western Europeans having too long periods of night sleep separated by hours of wakefulness might not be completely accurate.
It seems like the evidence for that specific pattern isn't as strong as people thought. The more natural human pattern, at least according to anthropological and biological evidence, and even, genetic evidence that we see in cultures that practice siestas, is it's more like a longer sleep at night followed by a shorter nap in the afternoon.
Okay.
So more like a main sleep and a nap.
Yeah, yeah. Which makes sense.
It does.
And then there's the example, I love this, the example of store hours in Greece back in the 1980s.
Oh, yeah, yeah. That really shows how this biphasic pattern was still influential.
Yeah, really interesting. So the book then goes on to explore how sleep patterns themselves have actually evolved alongside our human ancestors.
Right. So you've got Homo erectus, early humans, transitioning from sleeping in trees to sleeping on the ground.
Right,
That created a really interesting pressure on sleep.
right. Because you're safer, less likely to fall.
Exactly. So total sleep time became a little shorter, but the proportion of REM sleep actually increased.
So we traded quantity
Right.
for quality.
Yeah, exactly.
So it allowed our brains to, engage in more of that REM sleep dreaming
Yeah.
without the constant threat of falling.
Totally. Yeah. It's like our sleep became more concentrated,
Yeah.
packed with that high quality, brain boosting REM sleep.
So it seems like REM was like a key ingredient in our cognitive evolution.
For sure.
Yeah. And the book focuses on, two really important evolutionary contributions of REM sleep dreaming.
Okay. Let's hear them.
The first is emotional regulation.
Okay.
And it's this concept of therapeutic amnesia.
So through REM sleep, through that brain activity and the neurochemicals involved,
Yeah.
it helps to separate those strong emotions that are associated with our memories.
Okay.
So we can recall events without being completely overwhelmed by, the original emotional intensity.
It's like it's separating the recording of the event from the actual
The feeling of it.
feeling. Yeah.
Yeah.
Yeah. And the book talks about an MRI study
Right.
that actually showed reduced activity in the amygdala, the emotional center of the brain,
Right.
and increased activity in the prefrontal cortex, the part that's involved in rational thought.
Oh, interesting.
And this was after sleep, after being exposed to, emotionally charged images.
So it's like sleep helps to
Yeah.
process those emotions.
Yeah, yeah. And there's, Dr. Rosalind Cartwright's work on dream content
Yeah.
and the resolution of depression and anxiety after emotional trauma.
Right. Right.
It also supports this idea.
Yeah. And then there's Dr. Murray Raskin's research on using prazosin,
Right.
which is a medication, to help reduce nightmares in people with PTSD.
Yeah.
So, it all suggests that REM sleep functions like a master piano tuner for our emotional perception.
Okay, so we need that tuning.
We do.
And if we don't get enough REM sleep, what happens?
Well, that ability to interpret emotions accurately can be impaired.
Okay.
The book describes a study where participants were shown faces, some threatening, some friendly,
Okay.
and they use MRI scans to monitor their brain activity.
Okay.
And what they found was that sleep-deprived people had a much harder time correctly decoding those facial cues.
Interesting.
It's almost like viewing the world through frosted glass. You're
Yeah.
not getting the full picture.
Okay, so the second, big evolutionary contribution of REM sleep dreaming
Yeah.
is creativity.
Oh, yeah. This is where that backward Google search analogy comes in.
Yeah, explain that.
So REM sleep helps to forge these connections between, like, seemingly totally unrelated pieces of information in your brain.
Right.
It's like your brain is free to explore these distant associations in ways that our logical waking brain just wouldn't typically do.
Right.
And that can lead to those aha moments, those
Yeah.
insights, those problem-solving breakthroughs.
It's like it's coming up with solutions that you wouldn't logically be able to get to.
Right, exactly. It's not a linear process.
So interesting. Okay, so the book shares some classic examples of this.
Oh yeah, like Mendeleev's dream about the periodic table.
Oh yeah, I love that one.
It's a classic. Or Mary Shelley's inspiration for Frankenstein.
Right.
That apparently came from a dream.
And St. Paul Booth, the poet at work sign on his bedroom door.
Dedicated, right. Hoping to catch those dream-fueled ideas. But, beyond those anecdotes, there's actual scientific evidence from Robert Stickgold's research.
Right. He showed that the brain, during REM sleep, uses a totally different logic for memory association.
Right. It favors those more distant, unconventional links, not like NREM sleep or wakefulness at all.
And, he did that experiment, the number sequence task.
Yeah, where people who had slept were 3 times more likely to figure out the hidden rule.
Yeah, and the virtual reality maze, where the participants who had slept, especially that late morning sleep, rich in REM,
Right.
they were so much better at finding their shortcuts.
It shows that sleep isn't just passively storing memories.
Right.
It's actively working on them.
Yeah, it's like they're solving problems for us.
It really is.
Okay, let's talk about REM sleep and the developing brain in early life.
Oh, yeah. Really important.
Really important. So the book describes it.